Alrighty, so we are going to start talking about systems of equations. So hopefully you've gotten your notes packet from the sub. Hopefully you liked pretty green cover. I'm trying to, throw a little green in there. So topic 1, introduction to solving systems is where we're going to start. So these two problems have been written at the top. It says, can you solve the problem below? Ricky bought 2 bags of popcorn and 1 hot dog for $7. How much does 1 bag of popcorn and 1 hot dog cost? Set up an equation to help you. Okay, so 2 bags of popcorn. Well, I don't know how much popcorn is, so I'm going to say 2x plus a hot dog. Well, I don't know how much hot dog is, so I'm going to say y equals 7. Okay, so I'm going to give you a second to look at that and determine if you can actually solve that and tell me what does x equal and what does y equal. Okay, feel free to pause if you really think you can figure it out, because I'm about to tell you the answer. The answer is that you can't solve it. None of us can solve this problem because there's an infinite number of answers here. For example, maybe a bag of popcorn costs $1, which means that the hot dog would then have to cost $5, right? Or maybe the bag of popcorn costs $2, which then means that the hot dog has to cost $3. Or maybe the bag of popcorn costs $1.50, which means that the hot dog then has to cost $4. There's a bajillion combinations of these, right? Because there's no way to know what x and y equal. We also know this to be true because I could solve this for y, right? Y equals negative 2x plus 7. If I graphed that, I'm going to get an infinite number of points on this line that could represent the different costs of the hot dog and the popcorn, okay? So one equation with 2 variables, there's no way to solve that, okay? So let's look at the one beneath it. Will was painting his house. He bought 3 paintbrushes and 2 paint rollers for $34. How much is 1 paintbrush and 1 paint roller? Okay, so again, 3 paint brushes, so 3x, plus 2 paint rollers, 2y, equals $34. Okay, can I figure out how much x is and how much y is? Well, no. Again, I've got 2 variables here, so there's an infinite number of answers here, right? However, looking at these 2 problems, it's a real-world situation. We really can go to the store and buy a paintbrush, right? So there is an answer for x and there is an answer for y. But what's important is that what I've been given here is not enough to actually figure out what my answer is. Okay, I haven't been given enough information. So this is where systems come into play. Okay, so a system of equations is 2 or more equations, 2 or more equations containing 2 or more variables. Okay. Now, the variables have to match. So if you have one equation that uses x and y, it's only a system if there's another equation using x and y. Okay? So what is a solution? It is a point, which, remember, points are written as x, y, that makes every equation in a system true. Okay? Has to plug into every single equation and make all of them work out. Okay? Pause if you need more time. So let's look again at this whole popcorn and paintbrush thing and look at this example that I've given you here. I told you initially that the 2 popcorns and 1 hot dog was $7. Okay, so I gave you that here. Here's popcorn, here's a hot dog. All together, that's $7. Well, again, we have no idea how much 1 popcorn and 1 hot dog costs with just that information. But now I've given you another person's order. So a different person walked up there and just got 1 popcorn and 1 hot dog, and it cost $5. Using that, see if you can figure out how much 1 hot dog and 1 popcorn costs. I'll go ahead and tell you, because I've just given you a system of equations, 2 pieces of information, that you can actually figure out the answer. If you like the challenge, I would go ahead and pause it here and try to figure it out. I promise you can. If not, keep listening because I'm telling you the answer. So looking at this, if I kind of group this, I know that 1 popcorn and 1 hot dog is $5. So looking over here at the first person's order, 1 popcorn and 1 hot dog, that is $5, right? Well, if I know that altogether this was 7, that means that this guy right here has to be 2. And if I come back over here and I know this was 2, but altogether it's 5, hot dog has to be 3, which then aligns here as well, 3 and 2. So hot dog, we determined is $3. Popcorn is $2. okay? And again, the only way we were able to figure that out is because I gave you two pieces of information. I essentially gave you two equations. 3 popcorn plus 1 hot dog, I don't know why I put a 1 there, equals 7. And then over here, popcorn plus hot dog equals 5. I gave you two equations with the same variables, so we were able to figure it out. Okay, using that same logic, let's look back at the paintbrush and the paint roller problem. Okay, I initially gave you just the right side here. 3 paintbrushes and 2 rollers was $34. So using that same reasoning, see if you can figure out this one. Figure out how much just 1 paintbrush and 1 roller would cost. Pause it if you don't want the answer. Okay, so I know that over here, 2 of each is $28. So grouping off 2 of each here, that's 28. Well, that means that this 1 paintbrush here has to be 28 out of the 34, right? We have to take it away. And I'm left with $6. So I know that 1 paintbrush is $6. Okay, I'm going to go ahead and fill that in here. Well, if this is 6 and this is 6, that's 12 out of my 28 already taken care of, which leaves me with 14. 14 divided by these 2 gives me 7 and 7. I can go ahead and check my answer over here if I wanted to, see if this works out. 7 and 7 is 14. 6 and 6 is 12. Whoa, what did I do wrong here? 16. I did this wrong. I did it wrong. Sorry. This is why you shouldn't do things in your head. So because this was 12 away from 28, that's 16. There we go. Between the two of these. See, this is why you check your work. And I got 8 and 8. So the roller is $8. Okay, now let's see if that works. 8 and 8. That's 16 plus 12. That's my 28. Plus the 6 I have from before, and I get 34. Oh, I'm so afraid I'm going to do these completely wrong, and I'm going to come back the next day, and y'all are going to be like, miss, you got all that wrong. So if I did, I'm sorry. It's 7:30 right now. If you want to know the time, I want to go home. Okay, so there's just kind of a quick summary of systems. When you're given two pieces of information, so for this one to be like 2x plus 2y equals 28, and then over here, 3x plus 2y equals 34, you can actually combine the knowledge that you have for both of them to solve it and actually find a true value for x and y over here with popcorn, P, and H. So let's talk about the solution that you get. Again, going back to popcorn and paintbrushes and all that, there was really an answer. It was hot dogs was $3, popcorn was $2. Those are the only two numbers that I could plug in for the P and the H here and have this actually work out for both equations. Okay? So what we're going to do now is we're just going to test these without any popcorn or hot dog, just kind of looking at the bare problems. So it says determine if the point given is a solution to the system of equations. So on number 3, they've given us 5, 2. If this is a solution, it's going to be able to be plugged in here and here, and this should work out. So let's plug it into the top one. 2/5 times 5 minus 2 should equal 0. Well, 2/5 of 5 is 2. 2 minus 2 is 0. 0 equals 0. So that means for this first equation, check. It does work out. Okay, let's try it for the next one. Oh, I can't tell what that number was. 3. Okay, so I'm going to plug in a 5. Plug in my 2. Again, I'm getting these from this point right here. This is x and y, so I'm plugging them into x and y. So 15 minus 2, does that equal 13? Sure does. So, again, green check. This is a solution because it works for both. Okay, so let's try the next one. Again, my x here is -2, and my y is +2, so I'm going to plug those in. -2 plus 3 times 2 equals 4. Well, -2 plus 6, that is 4. So for this first equation, it does work. Second equation, let's try it again. -2 plus 2 equals 2. Well, -2, that's actually +2. Plus equals 2, not so much. 4 does not equal 2, okay? So because of that, it does not work with the second equation, so this is a no. That is not a solution to the system. Is it a solution to that first equation? Yes, but it's not a solution to the whole thing, which is what we're looking for, okay? Now would probably be a good time to pause. Try this last one on your own. Don't be afraid of the fraction and the decimal. Go ahead and pause if you want to work it out. Okay, here's your answer. So I'm going to plug these in, just like I've been doing. Here's my x and my y. So I've got y first. 0.3 plus 3 times 1/6 equals 9. So 3 times a sixth. I'm going to do top times top. So 3 over 6 is a half. I'm going to go ahead and change it to 0.5. Well, is 0.8 equal to 9? Absolutely not, right? Because it already does not work for the first equation, I'm going to just put a big old no before I even get to the second one, because I already know it doesn't work. Okay? So again, if it is a solution, it should plug into both equations and work out just fine. Alrighty? But now let's talk about how you actually get these answers. And I realize I'm kind of throwing a lot at you this first day, but really this is kind of the first and only day of learning. And then for the next like 8 days, we're just going to practice these same things over and over and over. So I'm throwing a lot at you today, but very little over the next few days. It's just a bunch of practice. So there's 3 methods to solving a system. We have graphing, substitution, and elimination. You actually already know how to do the first 2. You just may not have known that's what they were called. So let's start with graphing. To solve by graphing, you must have y equals mx plus b, or slope-intercept form. And you're going to use the slope and intercept to graph the 2 lines and find where they intersect. Okay, so again, you already know how to do this. So on number 1, y equals 2x plus 1. Here's my y-intercept, up 2 over 1, up 2 over 1. I'm going to go backwards here. I'm going to draw the line. Okay, there's my first equation. We do the second one. Y equals x minus 1. Remember, if it's just an x, that means it's got a slope of 1. That's 1 over 1. Just like we've learned with our line projects. Ooh, there's a point right there. So because those 2 lines intersected right here at this point, that means that is going to be a true solution for both of those equations. So my solution here is that point. Coordinates are -2, -3. So that's my solution. If you really wanted to check, then you could plug the x and the y into these coordinate or into these equations and see if it works out. But I promise you it is. Okay, so let's try again. Again, if you're feeling confident, feel free to pause and work ahead of me. So number 2, y equals x. You should recognize that as the parent function, right? It's got a y-intercept of 0 because there's nothing being added in the back. Slope of 1, so it's just going to go from corner to corner here. Okay, there's our mama parent function. Okay, the next equation, y equals -3x plus 4. It's a negative slope. Ooh, found my intersection right off the bat. There it is. 1, 1. Here's my solution. So again, if you wanted to check these numbers, you could plug them in here. Obviously 1, 1, 1 equals 1. If I plug it in here and here, that's going to work, right? If I plug it in here, 1 equals -3 times 1 plus 4. Well, guess what? 1 equals 1. That works. Okay? So we found that solution by graphing in this case. It's just the intersection of those 2 lines, because that is the point that those 2 things are going to share. Okay? So that's graphing. Check. Okay, substitution. You must know the value to one variable already in order to substitute. You're going to put a, this is a really tiny blank, a circle around that value and then plug it in into the harder, more elaborate equation. Okay, again, you've actually already done this, you just didn't realize that's what it was called. So look at number 3, it says x equals 3, and then 6x plus 3y equals 9. Well, again, a lot of us haven't realized that this right here is an equation. It looks like it's an answer, but it still is an equation, right? It's 2 things equal to each other. So because I know that x equals 3, that's what x equals, I'm going to then go plug it in for this x. Okay, so I'm going to rewrite 6 plus 3y equals 9. Okay, but instead of putting an x there, I'm going to plug in the 3 that was given to me at the beginning. Okay, so then I'm just going to work this out. 18 plus 3y equals 9. Working here to solve y. Divide by 3, so y equals -3. Okay, well, solution is supposed to be a point, an x and a y, right? So all I have found here is one of the values, -3. So what is x? Well, look back at your equations. X is, ding, 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 3. Okay, so again, substitution is kind of the easiest of the few, at least for today. As long as you understand that when they tell you that x is something, it's going to be that no matter what. So you're going to plug that 3 in for x if they've given you that x is 3. It's kind of like telling you that popcorn costs $4, so then you use that to find what hot dogs cost. Okay, so again, feel free to pause if you feel like you've got that. In this case, y equals negative 2. They just straight up told us that y is negative 2. So I'm going to plug it in for the y here. So I'm going to rewrite that bottom equation that's a little bit more complex. But instead of putting 4y, I'm going to put 4 times negative 2, because that's what they told me it was equal to. So 2x plus 8 equals 12. So x equals 2. So again, since they give me the x, that's the first part of the coordinate. And then I go back up to my problem, and they told me that y was negative 2. Total coincidence, by the way, that this just happened to be 3, 3, and 2, 2. Total coincidence. Okay, so that's substitution. Graphing, again, pretty easy. You just graph the 2 lines. It's where they intersect. Substitution, you just plug one into the other, work it out. You should have your answer. Okay? The last type is called elimination. This is the one that you've probably never done before unless you are working outside of my classroom on some math with somebody. It's also called the addition method sometimes. I do know a lot of private tutors or outside tutoring companies use subtraction here. I always use addition, so just so you know, that's what I'll be using in my class. So to use the elimination method, you must eliminate or cancel out one of the variables, right? If from the get-go we couldn't solve just one equation because there's too many variables there, let's just get rid of them, right? So we do this by adding the equations, okay? Before you can do this, however, you have to align your like terms using standard form. And that'll come into play more in the coming days. These are already aligned, as you'll see. We already have standard form in all of these, but just keep that in mind for the future. So I'm just going to add these 2 equations together. Okay, 2x plus 3x, that's 5x. Positive 2y and negative 2y, well, guess what? That's 0. Okay, these cancel out. Negative 2 and 12, that gives me 10. Now I have an equation I know how to solve. Divide by 5, so x equals 2. There's the first part of my solution. Now the thing that's different about this one versus substitution is I don't know what y is. I go back to my original equations and I don't see what y is. So I have to actually plug this 2 in to one of these guys to figure it out. So let's just take the top equation, for example. It originally said 2x plus 2y equals negative 2. Well, if I now know what x is, I found at least part of it, I can go plug that in for the x just like we did with substitution. So 2 times 2 plus 2y equals negative 2. Lots of 2's here. So 4 plus 2y equals negative 2. Subtract 4 on both sides. 2y equals negative 6. So y has to be negative 3. And there's my answer. Okay, so it's kind of part addition and part substitution, really. So let's try the next one. Again, they're both in standard form. They're all nice and lined up for me, so I'm just going to add those 2 together. Well, 4x and negative 4x, those are going to cancel. Negative 2y and 4y, that's positive 2y. 14 and negative 2, that's going to give me 12. Divide by 2, I know that y is 6 right off the bat. Okay, already got part of my answer. I can go put it down in the bottom. Y equals 6. But again, in order to get x, I don't have quite the easier time that I had with substitution. So I need to kind of go back up to these equations and use that y that I found to answer the rest of this problem. Okay, so let's take the top equation again. You don't have to use the top one, I just keep doing that. Okay, so there's my top equation. When I rewrite this, instead of doing y, I now know that y is 6. Okay, now I can just work it out. So 4x minus 12 equals 14. I'm going to add 12 to both sides. So 4x equals 26. Hopefully I didn't do something wrong here. Divide by 4, and x equals 6.5. Again, if that was supposed to come out evenly, sorry about that. But let's pretend maybe it really was supposed to be a decimal. So 6.5 would then be our x. I'm looking over my work. Negative 2 is 2, 12 minus 6. The other way I could check, honestly, if I'm being real with you here, is taking the 6 and plugging it in here, since I did the top equation before. So negative 4x plus 24. Nope, same thing. Okay, last one. Again, feel free to pause if you feel like you could do this one on your own. And this is the last part of the video, so check back to make sure you get it right, but then you're pretty much done. So I'm going to add these together. Those cancel, so I've got negative 3y equals negative 6. I'm going to divide, so y equals 2. There's part of my solution down here. Then I'm going to take that y and plug it back into one of these. Let's do the bottom one for fun. So I've got negative 3x minus, I'm going to plug in that 2 that I had just a second ago from my answer that I found. And that should equal negative 3. Again, these are the same thing. So I'm going to add 2 to both sides. So negative 3x equals negative 1. Divide by negative 3. So x is a positive 1/3. Alrighty. Let me make sure this is all I got. It is. Okay, good. So again, I know that that was a lot of information. Your homework is very, very simple in that it follows along with these examples perfectly. So as you're doing your homework, make sure you are looking at your notes that you just took. Ask each other for help. I will be back on Thursday, and I am going to just do this some more with you on Thursday. So I am more than willing to answer questions then, or feel free to email or send me a remind text.